In the last video, we saw how to use a new technique for solving quadratic equations called completing the square. But in every example we saw in that last video, everything turned out really nicely with no fractions whatsoever. In this video, we're going to look at another set of examples for completing the square, but this time with examples that lead to fractions. So things that get a little bit messier and more complicated. But the process will stay exactly the same. So let's take a look at this first example, and remember that our very first thing we have to do before we begin working on completing the squares, we have to make sure that the first coefficient that we see, the leading coefficient, is 1. In this case, when I see nothing in front of x squared, I know that its leading coefficient is 1. That's telling me that I'm free to begin the process. And as we begin the process, I want letters on the left and the numbers on the right. So I'm going to take this 1 and relocate it to the other side. So far, this doesn't feel any different than the examples we would have done in the last video. I now have letters on the left, and I have a number on the right. This is the point where we now want to complete the square. We want to add a magic number that will create a perfect square on this left side. The way we find that magic number is we're supposed to look to the coefficient on x, cut that number in half, and square it. But what number do we have in front of x? In this case, when I see nothing in front of x, I have a 1 there. If I took 1 and cut it in half, I now have a fraction. So this is where these examples will get a little bit more complicated. So I'm going to do a little bit of work off to the side to help us as we venture through finding the magic number. So the first thing I'll do is I'll look to the middle. The middle coefficient I'm seeing is a 1. If I cut that number in half, I get 1/2. Let's just leave it as a fraction. Don't write it as 0.5. Leave it as a fraction, 1/2. Now if I square that, keep in mind that squaring just means multiplying by itself. And so that means taking 1/2 and multiplying it by 1/2, and fractions just multiply straight across. So upstairs 1 times 1 is 1, downstairs 2 times 2 is 4. So when I looked to the middle, cut it in half, and squared it, my magic number is actually 1/4. And so when I add 1/4, I will complete the square on the left, but I have to maintain the balance by also adding it to the right side. This is where now knowing the pattern from the last video comes in real handy, because what I need to do now is show the left side factored as something squared. Now I don't want to do an X box to figure out what multiplies to a 4th and adds to 1. The faster way to go through this is to recognize that pattern from the last video, that if I look to the middle and simply cut that number in half, that will be enough. So I'm going to take the variable x from this problem, I'm going to look to the middle, I see a 1, if I cut that in half, I get 1/2. So going with the shortcut, going with the pattern is going to be a much faster way to factor rather than trying to do an X box with fractions. Now on the right side I have 1 plus 1/4. You may want to go off to the side to do that work. So when I'm adding 1 plus 1/4, let's rewrite the 1 as 1/1. So you can put whole numbers over 1. If I'm going to add fractions, I need an LCD. Multiplying is easy because I can just go straight across. Adding is more work. With adding, I need an LCD. In this case, between 1 and 4, the LCD is going to be 4. So I want both denominators to say 4. This guy's already fine. This denominator needs to be multiplied by 4. So I'm going to take 1/1 and I'm going to multiply it by what's missing, 4/4. Remember, we want to multiply by 1 so we don't change the value. So this gives me, if I go straight across, 1 times 4 is 4. Down on the bottom, straight across, 1 times 4 is 4. You can verify 4/4 is still 1. But if I have 4/4 plus 1/4, I wind up with 5/4. So it's going to take a little bit more work off to the side for us to figure out how does this work with the fractions. The process is exactly the same, but the fractions just kind of make us go a little bit slower because we have to think through all of the arithmetic. It's not as quick and easy as it would be with whole numbers. But at this point, we have something squared equals a number, so now just like we have in the past, we can go ahead and square root both sides. On the left side, the square root's job is simply to undo the square, so I wind up with just the x plus 1/2 on the left. But again, remember that as soon as the square disappears from the left side, a plus or minus will appear on the right. Now the square root of 5/4, it's not going to be perfect, but remember when we worked with roots, if we have one big root here, let's break that root into two pieces. So imagine breaking that root. I would have the square root of 5 over the square root of 4. Now the square root of 5 is not nice, so I'll just write square root of 5. But on bottom, the square root of 4 is just 2. And what I want you to notice is that at this point, the fractions that you have share a common denominator. That's a good sign that we're on the right track. Now to get x by itself, I'm going to relocate this constant 1/2 to the other side. I now have x alone on the left. On the right, I'll put my relocated number first, which is the -1/2. I'll put my plus or minus last, which is the plus or minus square root of 5/2. But now as one last step, simply because these fractions do share a common denominator, I'm going to go ahead and squish all of this together into one big fraction over that common denominator 2. And on top, I'll have the -1 plus or minus the square root of 5. Now I won't actually combine the -1 with the square root of 5 because they're not like terms, but because these fractions shared a common denominator, I can put this as one big fraction. But as we've seen before, this is again two solutions to a degree 2 equation. One answer says -1 plus the square root of 5 all over 2. The other solution says -1 minus the square root of 5 all over 2. Not a very nice looking answer. We had a lot of fractions as we were going through all of this, but if you can, try to look at the process and notice it's exactly the same. It's just the fractions made it a little bit more work on our part where we had to write down some steps instead of doing the arithmetic in our head. But it was the same stuff. Make sure that the leading coefficient is 1. Get letters on the left and the number on the right. Find a magic number that you add to both sides. That magic number will make this say something squared. When you have something squared equals a number, take the square root. The square root will undo the square, and then a plus or minus will appear. And then we isolate x. It's all the same steps as before. It's just the fractions make this look a little bit more complicated, and we have to sometimes think through it a little bit slower and off to the side. So let's try a few more examples, see if we can't get a little bit more familiar with and accustomed to working with the fractions. So again, before we can begin, we want to verify that the leading coefficient is 1. And in this case, when there's nothing in front of x squared, that means that our leading coefficient is in fact 1. So we can begin. And we're going to leave the letters on the left and move the number to the right. So in this case, that +2 will relocate with subtraction, moving itself to the right. And I have now x squared minus 5x equals -2. Now that the letters are on the left and the number is on the right, my job is to find that magic number that will complete the square. So let me set up some space to put that magic number, but because it's not going to turn out very nice, we're going to have to go off to the side to do some of our thinking. Because the part where we complete the square, that finding that magic number, we look to the coefficient on x, we take that number, we cut it in half, and we square it. But in this case, cutting -5 in half is not going to give us a nice whole number. So let's go off to the side. Let's think about what we would get when we look to the middle. Let's think about what we get when we cut it in half. And then we'll think about what happens when we square it. So when I look to the middle and see that coefficient on x, I see a -5. So in the middle, I see a -5. If I cut that number in half, let's not get fancy, let's just say -5 over 2. So we'll just say over 2 instead of cut in half. We won't get fancy. We won't use mixed numbers or decimals. Let's just leave it like that. Because when we square it, that means multiply it by itself. And remember, with fractions, I can multiply straight across. Negative times negative will be positive. Upstairs, 5 times 5 is 25. Downstairs, 2 times 2 is 4. So I wind up with positive 25 over 4. That's going to be my magic number. That's what I add to the left to create a perfect square, and I will add it to the right to maintain that balance. So again, as we're working with examples which don't have numbers that turn out very nice, it can be helpful to go off to the side to do the thinking. Again, you're taking that coefficient on x, you're cutting it in half, which just means put it over 2, and then you're multiplying that by itself to find what you get when you square it. So there's our magic number, and again, what that magic number has done for us is it has created for us a perfect square on the left side. And rather than thinking of an X box and thinking what multiplies to positive 25/4 and adds to negative 5, let's try and use that shortcut idea, that pattern. I'll use that variable X, but to figure out what goes here for my number, I just look to the middle and cut it in half. So when we took negative 5 and cut it in half, it was just negative 5/2. So again, to get your perfect square, you're looking to the middle and just cutting it in half, keeping the sign as well. Now on the right side, it looks like we're going to have a little bit of work to do because I am adding a whole number to a fraction. So again, off to the side, if I want to take negative 2 plus 25/4, let me write the negative 2 as a fraction, negative 2 over 1. And now to add these fractions, I need, again, an LCD. The LCD here would be 4. This denominator already says 4, which is great, but the other denominator just says 1, so we're going to have to multiply by what's missing. In this case, I need to multiply the top and bottom by 4. That will make the bottom say 4 there. And so my new first fraction, if I multiply straight across, I get negative 2 times 4 is 8. Across the bottom, 1 times 4 is 4. And you could just verify, negative 8 over 4, that's still just negative 2. It's the same thing. But it's written now to have a common denominator with the 25 over 4. Excuse me. So now if I add these, I keep my common denominator, and up top, negative 8 plus 25 is going to give me 17. So on the right side, I have 17 over 4. And after all this work off to the side, I have something squared equals a number. And so again, I can take the square root at this point. The square root will undo the square, leaving me with x minus 5/2 only. On the right, remember that as soon as that square disappears on the left, on the right, I need a plus or minus. And then let's think about that big square root. Remember, with our work from our work with radicals, if we have a big fraction root like this, we can break it into 2 pieces. So up top, I would have the square root of 17, which is not nice at all, over the square root of 4, which is 2. Again, notice we have the same denominator, which is a good sign. So now what I need to do is I need to relocate this constant. I'm going to add that 5/2 to both sides. And I'm running out of room here, so I'm going to erase some of our fraction work. And now that I've relocated that constant, I'll have x by itself. I'll put that relocated number first, followed by the plus or minus stuff. But again, like in the last example, because these share a common denominator, let's go ahead and mush them into one big fraction over 2. Up top, we'll have the 5 plus or minus the square root of 17. And because 5 and square root of 17 are not like terms, we can't combine them, this is where we end. Again, this is actually 2 solutions for this degree 2 equation. We have 5 plus the square root of 17 all over 2, and then we have 5 minus the square root of 17 all over 2. Let's take a look at another example. We just need to practice working with the fractions to get used to them. Let's take another look. Again, we begin by asking and verifying whether the leading coefficient is 1. And in this case, when I see nothing in front of x squared, I know that leading coefficient is in fact 1, so now I can begin. I'm going to leave my letters on the left and move my constant to the right, so the 6 will relocate to the right side using subtraction. On the left, I will now have just the x squared minus 3x, just those x terms. On the right, I have 0 minus 6, which is negative 6. And now that I have letters on the left and number on the right, my job is to find that magic number that will complete the square, that will create a perfect square on the left side. So I'm going to leave some space to put that magic number, but because this isn't going to turn out nice, I'm going to have to go off to the side to figure this out. So again, I have to think about who's in the middle, where's that coefficient I'm going to look at. I then have to cut that number in half. And then I have to square that number. This is how I find the magic number to add to complete the square. So first I look in the middle, I see negative 3 in the middle. If I cut that number in half, again, I don't want to get fancy, I'll just say put it over 2. So negative 3 over 2. Now if I square that, it means multiply it by itself. So I'm taking negative 3 over 2 times negative 3 over 2. Negative times negative is positive. Upstairs, 3 times 3 is 9. Downstairs, 2 times 2 is 4. So I wind up with 9/4 as my magic number. I'll go ahead and add that to the left. That will create a perfect square on the left side. But I also add it to the right. It will maintain balance that way. And again, the whole point of adding 9/4 here is to create here a perfect square. And so based on our pattern, remember we take our variable and put that in first. And now whatever goes here is this middle number cut in half. We said when we took that middle number, negative 3, and we cut it in half, we had negative 3/2. Now on the right side, again, we have a little bit more work because we're taking a whole number and we're adding to it a fraction. So let's go off to the side to do that work. We have negative 6, I'll say negative 6 over 1 that we want to add to 9 over 4. To add fractions, we have to have an LCD. When we were multiplying, we just went straight across. It was nice and easy. But when we are adding or subtracting, we need an LCD. Here, that LCD will be 4. For the first fraction, where the denominator is currently just 1, I need to multiply by 4 to get that common denominator. Keep in mind, we have to multiply top and bottom by 4. That's like multiplying by a value of 1. It will not change the value of this fraction. It'll just change the way it looks. So now it'll say negative 24/4 plus 9/4. And you can verify negative 24 over 4 is the same thing as negative 6. So we've just changed the way it looks. We have not changed its value. But now that I have a common denominator, I can go ahead and add these. This will be over 4. Negative 24 plus 9 will give us negative 15. So now I can put negative 15/4 on this right side. And again, what's happened now after all of that fraction work, I now have something squared equals a number. So this is now good. What I can do at this point is use that square root property. I will square root both sides. The square root will undo the square, leaving me with x minus 3/2. But again, be cautious that as soon as the square disappears from that left side, a plus or minus will appear on the right. Again, we want to imagine taking this root and breaking it into 2 pieces, but before we do that, notice there is a negative under that root. That negative tells me that this is imaginary, so there is going to be an I somewhere. So let's think about breaking this root. Let's think about putting that negative up here where the 15 is. If I had a negative square root of, or a negative 15 under the root upstairs, I have the I from the negative, and then I have the square root of 15. But now downstairs, the square root of 4 is just 2. So I have the I from the negative, upstairs I have the 15, downstairs I had square root of 4, which simplifies to 2. Again, notice you have a common denominator. Again, that's a good sign when you see that happening. Now the last thing I'll have to do to get x by itself is I will have to relocate this constant 3/2. I will add it to both sides. Now I'm going to have to erase here so I've got some room to do the last bit. When I write my answer, x equals, I'm going to write that relocated number first, so 3/2 comes first, then comes the plus or minus stuff. So I have plus or minus I square root of 15 over 2. But again, because these have the same denominator, let's go ahead and write this all over that same denominator. So I'll have 3 and then plus or minus I square root of 15 all over 2. And so now again, I have two solutions. I have 3 plus I square root of 15 all over 2. And I have 3 minus I square root of 15 all over 2. Again, that's two solutions to match the degree 2 equation that we had. Let's take a look at one more where we throw in an extra little kink and see if we can work through it. Okay, so here's a last example where I'm throwing everything at you that could make this stuff difficult. So remember, the first thing we need to look for is to make sure that there's nothing in front of x squared. In this case, there's a 2, and so what I need to do is divide that 2 off, but this is where this particular problem goes a little haywire. When I divide everybody by 2, not just the pieces that it's convenient to do so, 2x squared divided by 2 is x squared, which is what I want, but now I have negative 5x divided by 2. That gives me a fraction. And then negative 7 divided by 2 gives me a fraction. And then 0 divided by 2 is just 0. Those fractions are going to throw extra kinks into this operation here. Let's take it one step at a time. I at least have now no leading coefficient. So now I'm at least allowed to start the process. When I start the process, I want to leave letters on the left and number move to the right. So let's take this 7/2. Since it's negative, let's add 7/2 to both sides. And we will have x squared minus 5/2 x equals positive 7/2. So the fractions are kind of throwing us off, but the big picture is I've got x's on the left, I've got the number on the right. When that's the case, I can start looking for my magic number that I can add to both sides. So let's set up some space to add that magic number, and we'll go off to the side to figure out what it is. So again, when I find the magic number, I have to look to the middle. I'm going to need to cut that number in half. And then I'm going to need to square it. So when I look in the middle, what I see is negative 5 over 2. That's the number in the middle. What I need to do is I need to cut it in half. So there's a couple different ways you can view that. You can think cutting in half means dividing by 2. Or instead of saying divide by 2, you can just multiply by a half. And so imagine taking that negative 5/2 and multiplying it by a half, actually cutting it in half. I would get negative times positive is negative. Upstairs, 5 times 1 is 5, and downstairs 2 times 2 is 4. So I would get negative 5/4 is my cut in half number. If I square that, it means multiply it by itself. So negative 5/4 times negative 5/4, that's going to give me negative times negative is positive. 5 times 5 is 25. On bottom, 4 times 4 is 16. So it took a while to get there. You take your middle number. To cut it in half means to multiply it by a half, and then take that number times itself. We're getting 25 over 16 as our magic number. That's what we're going to add to the left to create a perfect square, but we're also going to add that to the right to maintain the balance. So now on the left, the whole point of adding that magic number was to create a perfect square. The shortcut that we can use to figure out what goes in here is we write down our variable first, and then we will look to the middle and say, take that number and cut it in half. Now when I took that middle number and I cut it in half, negative times positive was negative, Upstairs 5 times 1 was 5, and downstairs 2 times 2 was 4. So x minus 5/4 squared is my left side. Now on the right, I need to go off to the side and figure out how to add those fractions because again, where multiplying is quick and easy straight across, addition and subtraction is a little bit more work. We do need to find a common denominator. Here that common denominator is going to be 16. So our LCD that we need is 16. Right now this denominator's fine, but this one's missing something to become 16. So let's take that 7/2. If I multiply that by 8/8, it will create a 16 on bottom, but because I'm doing it to top and bottom, I'm not changing the value, which is really important here. So 7 times 8 gives me 56 on top. 2 times 8 gives me 16 on bottom, and I'm adding this to 25/16. So if I add 56 plus 25, I'm going to get 81 all over 16. That all looks nasty, but that's actually going to turn out really nice in a moment here. So we've got on the right side 81 over 16. Now I am way out of room. I'm going to have to erase all this work here. But what I can see is that through all of this fraction work, I've created a scenario where again, I have something squared equals a number. We're on the right track. Once I have something squared equals a number, I can take the square root on both sides. So if I've got x minus 5/4 squared equaling 81 over 16. Something squared equals a number. Let's take the square root on both sides. The square root will undo the square, leaving me with x minus 5/2. Keep in mind though, as soon as that square disappears on the left, a plus or minus now appears on the right. And this is where I promise that even though this looks nasty, this actually turns out really nice because imagine taking this square root and breaking it. The square root of 81 is exactly 9. The square root of 16 is exactly 4. Now in this particular case, I don't appear to, oh, I wrote this wrong. This was negative 5/4. There we go. How did I catch that mistake? I want to see an LCD here. I copied that wrong. So this was minus 5/4, and now I do see that I have that common denominator. Whew, that's good. So now I want to take this 5/4 and relocate it to the other side. I will add it to move it. Now I've got x equals, I'll put that relocated number first, then the plus or minus. And now because these have the same denominator, I'm going to go ahead and squish this all over 4. Upstairs will be 5 plus or minus 9. And in this case, we actually have like terms. 5 plus 9 can be done and 5 minus 9 can be done. Let's take a look at this. 5 plus 9 gives me 14. 14 over 4 reduces to 7/2. 14 over 4 becomes 7 over 2. If I try the subtraction, 5 minus 9 is negative 4. Negative 4 over 4 is negative 1. This one actually had nice numbers for the solutions, but again, it's 2 solutions for that degree 2. Now, I'll tell you something. This was a very long and complicated process to have to deal with all these fractions. We're not going to have to do that all the time. What we're eventually going to do is after we learn all these different solving techniques, we'll make decisions on how do I know which is the most quick and efficient and painless way to get through a problem. The fact that these solutions came out to be nice fraction or whole numbers versus square roots or imaginary numbers, the fact that these were nice meant that there was an easier way for us to go through this. We didn't have to go through all this pain of fractions. But it's good practice for us to learn this technique. Again, the power behind completing the square is that it works for any quadratic equation. In the next video, we're going to look at one more technique, a fourth and final technique for solving quadratics. using what we call the quadratic formula. It's another technique like completing the square that works for all quadratic equations, but you'll see it's a nice simple plug and chug. We don't necessarily have to work with all the fractions that we do in this situation sometimes.